And so our initial reaction was that, well, it cannot be that distant because it's too bright.
I don't think we can stress enough on the point that the universe is really weird. For as long as any of us have been alive, we've been told one story about how it all started. It begins 13.8 billion years ago with the Big Bang. From a single cosmic seed, everything we are, everything we see, expanded into the cosmos we know today. It's a story we thought was solid, confirmed by decades of science. But what if that story is wrong? What if the official rulebook for the universe needs a serious rewrite? Our most powerful eye on the sky, the James Webb Space Telescope, is peering back to the dawn of time, and it's finding things that just shouldn't be there. And this isn't just some quiet debate anymore. When a Nobel Prize-winning physicist, one of the people who wrote the rulebook, says we might have, quote, misunderstood the universe, it opens the door to some truly wild possibilities. The kind of possibilities that suggest what the telescope has found might be the most important and unsettling discovery in human history. Okay, so to get why these new discoveries are so earth-shattering, you first have to understand the story they're messing with. For about 50 years, cosmology has been dominated by one idea, the Standard Model. Think of it as the official prize-winning history book of the universe. It's been incredibly successful, explaining everything from the leftover heat, from the Big Bang to the giant web-like structure of galaxies. The story goes that after the Big Bang, the universe was a hot, soupy mess. It was like a kitchen where all the ingredients for stars and planets were mixed together, but it was still just a chaotic batter waiting to be baked. For millions of years, it was dark. Then gravity, acting like a slow, patient chef, started doing its thing. The standard idea is that this was a bottom-up process. Like building a giant Lego castle, you can't start with the whole castle. You need individual bricks, the first stars, and then you build small sections, the baby galaxies. Only after billions of years of smashing these sections together do you get the huge, majestic castles we see today. This takes time. A lot of time. Our models were clear. You can't get a big, mature-looking galaxy for at least 1 billion years. And this is exactly what the $10 billion James Webb Space Telescope was built to prove. It's a time machine designed to see the universe's first Lego bricks and confirm our construction manual was correct. Webb opened its golden eye and, almost immediately, that neat, elegant story started to look shaky. Imagine you're an archaeologist who knows for a fact that complex cities only appeared after thousands of years of small settlements. Now imagine digging down to a layer you know is 10,000 years old, expecting to find stone arrowheads, and instead you find a smartphone. That's pretty much the shock that hit astronomers. Webb was finding the cosmic equivalent of a smartphone in the Stone Age. Deep in the cosmic past, just 280 to 300 million years after the Big Bang, Webb saw galaxies that were enormous, brilliantly bright, and already structured. These cosmic oddballs, nicknamed universe breakers by the media, are so massive they challenge the whole timeline. They just showed up to the party way too early. This cosmic headache is piled on top of another long-running mystery, the Hubble tension. For years, we've had two different measurements for how fast the universe is expanding. It's like trying to find out how fast a car is moving using two separate tools. One is a radar gun measuring its speed right now by looking at nearby stars. The other is calculating its speed based on the car's original design specs by studying the afterglow of the Big Bang. Both methods are super precise, but they give you two different speeds. They don't match. Everyone hoped Webb would fix this. It did the exact opposite. Webb's data just confirmed the radar gun's measurement with even more certainty. The disagreement is real. It's like confirming your car is going 70 miles per hour, while the engine specs say it can't possibly go over 50. The beginning of the universe and the universe today are not adding up. When your trusted theory starts to show cracks this deep, you listen very, very carefully to the people who built it. One of those people is Adam Rees. This is a guy who won a Nobel Prize for co-discovering the universe's accelerating expansion. He's a key architect of the Standard Model. After reviewing the Webb data, which ruled out simple measurement errors, Rees said something that sent shockwaves through science. With measurement errors negated, what remains is the real and exciting possibility that we have misunderstood the universe. Think about that. This is like the chief architect of a world-famous skyscraper admitting that the original blueprints might be fundamentally wrong. It's a polite, scientific way of saying something is deeply wrong with the picture. So if our trusted theories are buckling, what's the answer? These warnings have cracked the door open for ideas that used to be on the fringe. Think of these as the wildcard theories that scientists keep on a high shelf for emergencies. Now, it's an emergency. If our current physics can't explain what we're seeing, maybe we need different physics. And that brings us to Sir Roger Penrose. Penrose is a legend. He won his Nobel for proving that black holes are a definite consequence of Einstein's theories. But he's also championed a wild, mind-bending idea called conformal cyclic cosmology, or CCC. He developed this theory long before Webb ever launched, but its findings are making some people give his extraordinary vision a second look. Penrose's theory doesn't just tweak the Big Bang, it gets rid of a single beginning altogether. So what is conformal cyclic cosmology? Imagine the universe not as a single story with one beginning and one end, but as a phoenix, endlessly being reborn from its own ashes. Penrose suggests our Big Bang wasn't the beginning, but just one aeon, like a single chapter in an infinite book. In his view, each universe expands for trillions of years until everything in it has dissolved into pure energy. At that point, the unimaginably vast, empty future of one universe essentially becomes the hot, dense Big Bang of the next. The end of one cosmic chapter seamlessly triggers the start of a new one. The Big Bang wasn't a unique creation, it was a transition. For years, this was just a fascinating thought experiment. So how does this connect to Webb? Penrose speculates that some of Webb's impossible galaxies might not be young galaxies from our universe at all. He suggests they could be remnants from a previous aeon, cosmic fossils that survived the death of their universe and crossed over into ours. The massive black holes at their centers could be Hawking points, faint heat signatures left over from the previous universe, like the warmth left on a stovetop long after the pot has been removed. Let's be absolutely clear. This is a speculative theory, far from the mainstream. There is no direct evidence from Webb that proves this. But the fact that Webb's data is so puzzling is forcing scientists to have these conversations. The telescope's findings are so bizarre that they are breathing life into theories that were once considered the outer fringes of physics. If this is right, Webb hasn't just found old galaxies. It may have found the first evidence of another universe. The discoveries are forcing a complete re-evaluation. Are we seeing ghosts from a past universe, like Penrose suggests? Or maybe it's evidence for other fringe ideas, like the hypothesis that our universe might exist inside a black hole? Or will a less exotic, but still revolutionary, new physics emerge? These anomalies are not failures. They are signposts pointing toward a deeper reality. It's as if we were drawing a map of the world and suddenly found a new, hidden continent. As Adam Rees said, they present an incredible opportunity to learn more about our universe. We thought we were mapping the edges of our known world, but we may have found a doorway to something else entirely. The James Webb Space Telescope was sent to answer old questions, but instead, it has given us new ones that challenge the very meaning of a beginning. We are living through one of the most exciting periods in the history of science, where every new image has the potential to rewrite our textbooks. If you want to stay updated on more mind-blowing discoveries that challenge our reality, make sure to subscribe and hit that notification bell. The universe is far stranger than we thought, and you won't want to miss what it reveals next. What Webb has found in the darkness is not what we expected. It discovered cosmic giants where there should have been infants and order where there should have been chaos. These findings have shaken cosmology and forced Nobel-winning scientists to admit we may have misunderstood the universe. The theories being discussed are no longer just about tweaking a timeline. They're about questioning if there was only one. The most profound of these ideas suggests we might be seeing fossils from a universe that existed before our own. So, what do you think? Are these galaxies a glitch in our current theories, a sign that we need a new piece for the puzzle? Or are they the first tantalizing glimpse of a reality far grander and more ancient than we ever dared to imagine? Let us know your thoughts in the comments below.